Alrighty folks, we are going to be talking today about visualizing rates of change, and this should be some review for most of us. If we're just rates of change, is basically we're just talking about slope, and slope, if you remember, comes from a very simple formula, and that is simply rise over run. So the rate of change is just a slope, it's like a unit rate, and rise over run. We can also express that in a few other ways. You may have seen that one with the equation there from last year. We're looking at the difference in the y coordinates, which is the rise, the vertical axis, divided by the difference in the x coordinates, which is the horizontal axis. Or you can also write it this way using Greek letters, which means the exact same thing. And that's a delta, not a triangle. So it's delta y divided by delta x. It just means a change in y divided by the change in x, or the rise, the vertical change divided by the run or the horizontal change. Okay, and these are all examples of some unit rates we've seen before: kilometers per hour, dollars per hour, dollars per gram, dollars per kilometer to drive a car, that kind of thing, and that's fairly straightforward. And so if you're to look at, say, for example, kilometers per hour, given that that is a rate, a unit rate, and therefore can be expressed as a slope, that means that kilometers per hour is also equal to the rise divided by the run. In other words, kilometers per hour means that the rise is kilometers and the run is hours. And what that means is if we were to make a graph that to figure out the speed of something, we would plot it with the kilometers, the distance, being the y-axis, and the run being the time as the x-axis. Okay? And that goes for anything. If you're talking about dollars per day or grams per milliliter, whatever the per thing is, so like per day, per milliliter, these are all going to be the x-axis. So just keep that in mind when you're graphing something, that the per blank, the blank goes on the x-axis, the thing in front of the per goes on the vertical axis. So then for our kilometers per hour, if I was to make a graph, then I would put kilometers on the vertical axis and hours on the horizontal axis, the x-axis. Okay, and then we could plot data and calculate a slope based on that, which we'll get to in just a second. Okay, so here's an example of something we can look at, looking at your age versus your height, and we all know we get taller, hopefully, as we get older to a certain extent. And if we wanted to find out our average growth per year, our height change per year, so just by saying that, I should know that per year, that means that years are going to go on my horizontal axis. So if I were to draw a graph, it would look something like that, where obviously this is my height on the vertical axis, and this is my age or time in years on the horizontal axis. I can plot my points. So at 2 years old, this person was 90 centimeters, and at 18 years old, this person was 180 centimeters. Okay, and I can connect the dots with a nice line, and that shows me their average rate of height of growth per year. Okay, and to figure it out, to calculate it, is just simply calculating the slope. In other words, the rise over the run. So we can draw a nice little right triangle here, just like that, and then we can look at the rise and the run. So to do that, count how many spaces there are. Don't look necessarily at the numbers. So I would start here, let's say, and go 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces, but each space is 10 centimeters. So this is 10, 20, 30, 40, etc. up to 90. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. That's 100 centimeters. Sorry, I counted those wrong. This is where I start, and then so I go 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 90. Duh. The difference is obviously a difference of 90. I get it from there. And the difference in years obviously is going to be 16. So if you're to count spaces, it'd be 16 years. Okay? And so to calculate slope, you're going to go rise, 90 centimeters, divided by 16 years, and you get an answer of 5.6 centimeters per year. Okay, so we're going to have a look at another example in the next video, so let's skip to that one now.